Good morning, everybody. Welcome back from winter break. I hope your break was enjoyable. So you need to get back into the education frame of mind, however. So today we are starting with Chapter 5. The first is displacement and force in two dimensions. The first section is addresses vectors. And what vectors are, they are, if you remember, we talked about physical quantities back in Chapter 2. And a vector is a physical quantity that represents both a magnitude and a direction. So direction could be north, south, east, west, something like that. Now we can use vectors to represent, for example, the amount of force that is being applied in a particular scenario. So for example, what I have up here on the board, a couple of arrows here, 35 newtons. This could represent something like you and your friend are both pushing a cart in the same direction down the hallway, and each of you are applying 35 newtons. So this is basically vectors in one dimension. Now, a lot of times with vectors, the longer the line is, the greater the magnitude of the vector is, or force, or whatever you happen to be discussing. Now, vectors can also be utilized in multiple dimensions. And the two cases we're going to look at here are dealing with Pythagorean theorem, which you might remember that from a math class you've had previously or you're currently taking. And there's also what we call the law of cosines. All right, now you're going to use one of these two laws. There's a couple formulas here which I have up on the board. You're going to use one or the other in solving a problem. All right. Now, to go along with the law of cosines, this is a good time to either A, introduce to you the three trigonometric ratios, the three basic trigonometric ratios, or perhaps B, it's a review for you, depending on how much math you've had. So the trigonometric ratios are called sine, cosine, and tangent. There's those little mnemonic ways of thinking to help you remember, what means what here. See, the trigonometric ratio, sine is referring to the length of the side opposite the angle that you're talking about over the hypotenuse. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and then tangent is opposite over adjacent. Now, we can use this little device, if you will, to help you remember it. Basically, what it's called is SOHCAHTOA. And when I was in school, the teacher said, "Oh, well, it's a Native American chief, like the leader of a tribe, for example." So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. On the vectors worksheet that's posted in Google Classroom, one of the questions asks you to write out the definitions for sine, cosine, and tangent. All you really need to say is sine is, you can just write opposite over hypotenuse, and cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You don't need to write out a long definition or anything like that. Okay, so what we have here, a couple of problems that I've done for you. And so the first example here, we are looking at a car is driven 105 kilometers east and then 42 kilometers south. What is the magnitude of the displacement? One of the things you're going to be asked to do is to draw a picture. And what I mean is a diagram like this. So if you have trouble envisioning north, south, and east and west, you might want to, after you watch the video, take a look at Google that information and try to get that straight in your mind, if necessary. So, because the angles, the vectors here are meeting at a right angle, okay, we are going to use the Pythagorean theorem. Pythagorean theorem, according to one way to write it, is r squared equals a squared plus b squared. You probably know it better as a squared equals b squared, or a squared plus b squared equals c squared. All right, you might know it that way. But it's the same idea. It's the same operation, same everything. It's just that instead of calling the hypotenuse c, we're going to call it R, because R stands for resultant, and resultant refers to the sum of vectors. So what I did here is, so we square 105, all right, and then square 42. So when you add up those two values, you get 12,789. It's really important that you remember that that's R squared and not R. Don't leave this as your final answer, because your answer really won't make sense. And then when you take a square root of it, you get 113.08. And really, your final answer should be less than the sum of these two numbers. If you add up 105 plus 42, you get 147. All right, that's saying, okay, I'm driving 100 kilometers this way, 105 kilometers this way, and then 42 kilometers this way. That's 147. But if you take this way, you know, the shortest distance between 2 points is a straight line. This answer here, your answer should be less than the sum of these two numbers. So anytime your vectors are meeting at a right angle, then you're going to use Pythagorean theorem. Now, and again, you're going to have to draw a diagram. Well, it's going to ask you to draw diagrams. You might just have to put that on scratch paper or whatever. As long as you're showing me the problem, that's fine. Now, there's also the law of cosines. This formula is going to be used anytime you're not going to use the Pythagorean theorem. How are you going to know? Well, you read the problem carefully. A car is driven 37 kilometers due east before it makes a 135-degree turn to the right and travels another 18 kilometers. It's basically like making a 45-degree turn. That's basically what this is. But we're using the inside angle, and that's pretty much spelled out for you on the worksheet. All right, so you got this formula here for law of cosines. R squared equals a squared plus b squared minus 2ab cosine theta. Say that 5 times fast, right? So 37 squared is 1,369. 18 squared is 324. And I just plugged everything else in. Now, when you do cosine of 135, which is really what I want you to do, you're going to end up with a negative number. And it's negative 0.707, whatever else comes after it. When you multiply 2 times 37 times 18 times negative 0.707, you end up with a negative number. All right, this number here is the result of adding 1,369 plus 324. I get 1,693. You're going to subtract the negative. So in essence, you're adding these two numbers. I get my answer here. And then remember, I want to take the square root of it because this is R squared. I want to know what R is. Final answer came out to be 42.28 kilometers or 42.3 kilometers. You can round to the nearest tenth or leave it 42.28 in this case. It doesn't really matter, whatever you prefer. So that's how we focus or we work through these types of problems. Again, draw a picture. It says on the worksheet to do that, but okay, it's in Google Classroom, so have a scrap piece of paper right there handy for you. It helps. All right, I recommend that you draw a picture, especially if you have trouble envisioning north, south, east, and west. Now, I'm going to address with you a couple other things. I'm going to move the iPad over to the other side of the room here, so that you can better see the chalkboard. So here we go. All right. Now, here's a couple questions that we're going to address that are on the worksheet, and I want to make sure that we have an opportunity to talk about this. So the question reads, is the distance that you walk equal to the magnitude of your displacement? Provide an example to support your answer. Okay, so if you think about this, if I say, all right, we're going to start here in my classroom, which this is room 309 for those of you who may not know, and we're going to go out in the hallway and we're going to walk, go outside the building. Let's say we're going to walk 2 laps around the entire building, and let's face it, we're going to cover a certain distance. If you have a pedometer app on your phone, you're going to log in a lot of steps while we would do that activity. Now, the thing is, we're coming back to where we started from. So when you do that, when you come back to where you start from, such as walking laps, another couple examples here. If you run track and you run the 1600 meter relay, then you're coming back to where you started from. You're still running. You're still using energy, burning off calories, etc., etc. But you're still coming back to where you started from. Your displacement is 0, right? But you still covered a certain distance, okay? Now, same idea is if you go around the block, all right? Let's say, you live here, and let's say you go out and you let's say you go out and you walk this distance, let's say it's 1 kilometer. Walk over this way, here's another kilometer. Up this way, another kilometer. And finally back home for a total of a 4-kilometer trip. You came back to where you started from, so your displacement is 0. So the answer to the question is the distance you walk is not equal to the magnitude of your displacement. All right? If you're in a NASCAR, what do, they drive around a track, they're constantly making left turns. They put 500 miles on their car, but they're really not going anywhere because they're just going in circles. Okay, so that's basically how you would answer this question. And of course, if you need to Google it, that's fine. But do not copy and paste directly from whatever website you find. Try to put it in your own words because that's how you remember it. Last thing here. This is about the commutative property. Commutative property, with addition and multiplication. If I say 3 plus 2 equals 5, well, doesn't 2 plus 3 also equal 5? And same thing if you're multiplying. 2 times 3 is 6, and 3 times 2 is 6. So with the commutative property of addition, and multiplication for that matter, the order of the factors doesn't matter, all right, with multiplication or addition. But with subtraction, it does. If I say, all right, 5 minus 3 is obviously 2, and then if you say, well, okay, what's 3 minus 5? Well, that's negative 2. Those aren't the same values, right? If there's a difference of course, between negative 2 and positive 2. All right, so that's just something to keep in mind. That question is addressed here on the vectors worksheet. So just to kind of wrap things up again, you have the Pythagorean theorem, and you also have the law of cosines. And there we go. It helps to draw a picture. Again, the directions on the worksheet say to do that, but I didn't really tweak the directions to be put on Google Classroom. So you don't have to show me pictures if you don't want to, but again, you're encouraged to help, especially help you visualize what's going on. So if you have a right triangle, it's Pythagorean theorem. If you don't, then you're dealing with the law of cosines, Pythagorean theorem formula, and the law of cosines formula. If you have any questions, feel free to email me, and I am more than happy to give you a hand. So knock out this worksheet, and it's not due till next Tuesday, January 12th at 11:59 in the evening.